Okay, now we're going to go on to lesson number 3, which has to do with multiplying decimals. And again, I just want to encourage you guys to be a good student. You've got the same notebook, you're on the next page in it, so everything's in the same place. You got multiple colors of pen out, so you're ready to roll. You can highlight things and write things in different colors, and it'll stand out better for you visually. And basically, where I'm kind of semi-training you to be a better student and also to understand these concepts. So let's jump right into it. Um, so if you look on my screen here, I have multiplying and dividing decimals. My encouragement is press pause, copy everything down, then press play, and we'll go from there. All right, having said that, what I'm going to talk about first is I want to talk about this rule. Okay, the rule is that whenever you're multiplying a decimal, you're going to multiply the numbers like normal. So like I have on my screen here, okay, got this kind of cool little highlighter thing here. You're going to multiply the numbers like normal. Okay, you're going to do that, and then count how many numbers there are to the right of the decimal place in both original numbers, and then you place the decimal that many places to the left in your answer. I know that's kind of a mouthful, but I'm going to show you what that means here. So I'm going to start by a fairly simple example here. So if I take, for instance, the number, the first example, and I take 4.36 times 2, and I said that what you're supposed to do is you're going to multiply like normal, 4.36 times 2, okay? Because that's the first thing, is multiply the numbers like normal, it says. All right, so I'm going to go ahead and just do my math here. 6 times 2 is 12, carry the 1. 3 times 2 is 6, plus 1 is 7. And then 2 times 4 is 8. Okay, so the big question in multiplying is, where does that decimal go? Okay, well, my rule says to then count how many numbers there are to the right of the decimal point place in both original numbers. Okay, so if I look here on the screen here, I've got both of my original numbers here. Here's 4.36 and here's 2. How many numbers are to the right of the decimal point? Well, at the top here, I see 2 numbers right here. These 2 are to the right of the decimal point. In the bottom number, there's nothing. So there are 2 numbers to the right of the decimal. Okay, so then it says place the decimal that many places to the left in your answer. I'll show you what this means. You start over here on the far left here, okay, and you count 2 places, uno, dos, okay, 1, 2, and I got 8.72, and that's where my decimal point goes, okay? Again, in the next example, I've got 0.92 times 9, and I'm going to just do the math like normal, okay? 9 times 2 is 18, carry the 1. 9 times 9 is 81, plus 1 is 82, okay? Big question is, where does that decimal go? Okay, in the original whole problem, and that means both numbers, okay, don't forget that. How many are to the right of the decimal? Just 2. So I'm going to start at the far end here and go 1, 2. That's where I'm going to put my decimal point, is right here, 8.28. Okay. Now I'm not going to do number 3 and number 4. I'm just going to ask you, in number 3 here, in this equation here, when I get my final answer, how many places am I going to move my decimal from the right to the left? Okay, pause there for a minute for you. I'm going to count in my original answer. I've got 3 here to the right, plus I got 1 here, 4. So once I've done my math, I'm going to start here over on the far right and go 1, 2, 3, 4 places and put that decimal somewhere in my answer. Look at number 4. How many places am I going to have to move my decimal when I'm done doing the math? Look at the whole problem. I see these 3 numbers here are all to the right, so I'm going to move it 3 places to the right. Okay. All right. Let me show you an example of a multiplication. I also should show you this concept here. Okay. It's called front end rounding and then multiplying. So you probably should freeze the frame, copy down the notes here, and then press play. Okay. So front end rounding says there's a rule, and that rule is to round each number to the leftmost place. Okay. And this is what's called front end rounding. I'm going to put little quotation marks around this, okay? So this is the concept where they call it front end rounding, okay? So you're going to round each number to the leftmost place that does not, I'm going to underline this 3 times, okay, does not have a 0, and then multiply the rounded numbers. So sometimes you'll see a story problem like this. Use front end rounding to estimate. This word estimate is the same as rounding, okay? The answer to 2.84 times 0.72. All right, well, let's just take 2.84. Front end rounding means I'm rounding to the leftmost place, okay, that's not a 0. Well, in 2.84, this is my number here that is the most to the left. And to round it, I look at the number to the right of it, and I ask myself, is this 8 right here? Is this 8 5 or more? If it's 5 or more, then 2 would round up to 3. And it is. So I'm going to round this up to 3. And everything else is just kind of like zeros, okay? So it's just 3. So 2.84, if I front end round, it becomes 3 times, okay, because we're still doing the same problem here. I got 0, this thing here, 0.72, that decimal. Now, front end rounding says it has to be the leftmost number that's not a 0. So I'm doing nothing with this 0 here. So it's 0.72, so it's really 0.7 here, okay? Now, look at I'm going to underline the number I'm rounding to. Look at the number to the right. It's not 5 or more. So 7 is going to stay the same. So it's really 0.7, okay? Now, so that's what it rounds to 0.7. It stays the same. If I just did the math, 3 times 7 is 21, right? Where do I put my decimal? Do you remember we just went over this? In the whole original problem, how many numbers are to the right of the decimal? 1, just this one right here, okay? So I'm going to move my decimal point 1 place to right here, and that's where it would go. So folks, that's how to multiply decimals. One more thing. Let me see if I can show you like a story problem, okay? Yeah, this is a good example right here. Look at this first one at the top. It says Jane earns $14.90 an hour. Okay, so I'm modeling for you. I'm underlining an hour. Each hour she earns this much money. Okay, so I'm kind of like highlighting these ideas as I'm reading this equation of overtime. How much does she earn for 2.3 hours of overtime? Okay, this is a good example of a story problem where you're multiplying because she makes $14.90 an hour, but she worked 2.3 hours. So how much is that? How much does she make? Okay, and again, it could say total, right? And I did mention earlier that total could mean adding or multiplying. So what you would do is $14.90, 14.90. Okay, I'm taking the number from the equation times 2.3. Okay, so that's what I'm doing. Notice I'm not lining up my decimals because this is a multiplication problem. Okay, then I would do my math. Okay, if I do it real fast here, 7 to 12 or 14, carry the 1, 2 times 3 times 1 is 3 plus 1 is 4, and then I'm going to multiply this second number underneath here. I get 0. Notice where I put that number there. I skipped a space. Okay, I get 18. Carry the 1. By the way, I should have erased these. Okay, 2 times 4 is 8 plus 1 is 9. 2 times 1 is 2. All right, so if I add all these things up here, I got 0, 7, this becomes a 12. That's 14 if I add these up together, and a 3. So I got 3, 4, excuse me, it's a little bit of a mess. 3, 4, 2, 7, 0. Now, in the original problem here, how many numbers are to the right of the decimal point? Well, I'm just kind of circling them. I've got 3, so I start here and go 1, 2, 3. My answer is I got 34.270. That's how much I made, okay, in 2.3 hours. All right, next example is 1 inch is 2.54 centimeters. A 12-inch ruler is how many centimeters long? Well, if 1, okay, equals 2.45. See how I'm modeling this for you? I'm writing the numbers on my page here. One of them equals that. How many centimeters is I've got 12 equals how many centimeters, okay? Well, I'm going to take, in this case, can you guess what you're going to do? I'm going to take, it's a 12-inch ruler here. This is my number here. That's where 12 came from. And I'm going to multiply it by 2.54. So probably what I would do is write it like this: 2.54 times 12, okay, because there's more actual digits on top. That's why I put it on top, okay? I would do the math, and then in my answer, I'd move my decimal point 2 places over because there's 2 numbers in the problem that are to the right of the zero.